Hello, thank you for joining me today, and today we'll be going through the white matter. White matter is made out of nerve fibers in the neuroglia, and they lie deep to the cortex, and it's made out of all these fibers. So the association fibers are up first. There are the short association fibers, which are the arcuate fibers, and they wind around the sulcus and interconnect the adjacent gyri. So they're like here, they're here, they're here. The long association fibers travel long distances and they connect the gyri of different lobes. And they're usually grouped in a bundle. So here's one, here's one. The uncinate fasciculus is going to connect the motor speech area and the orbital cortex of the frontal lobe along with the temporal pole. And the cingulum is the limbic association bundle, and it's in the cingulate and the parahippocampal gyri. So it will go from the paraterminal gyri to the uncus. The superior longitudinal fasciculus is the longest, and it connects the frontal lobe to the occipital lobe along with the temporal lobe. And the inferior longitudinal bundle is going to connect the visual association of the occipital lobe to the temporal lobe. The frontal occipital bundle will run backwards, and it lies deep to this superior longitudinal bundle, and it's separated by the corona radiata, so it's on both hemispheres. Okay, the commissural fibers will carry the interhemispheric information for bilateral processes and learning processes, or bilateral responses. So these will connect like the two hemispheres together. The corpus callosum is obviously the largest, and the anterior and lower temporal lobes are going to be connected by the anterior commissure. The corpus callosum is made of 4 parts. There's the geno, the body, the isthmus. The geno, the rostrum is up front. Here's the body or the trunk. And then the rostrum or the isthmus and the splenium. It depends on what anatomy book you used, but I know it as the geno, rostrum, trunk, and splenium. But as long as you know where the rostrum, splenium, and geno is, I'm pretty sure we can figure it out. So the geno is up front, lies behind the frontal poles, connects both frontal lobes. And the rostrum is going to connect the orbital surfaces of the frontal lobe and the lamina terminalis. The trunk or the body is going to connect the frontal and the anterior part of the parietal lobe. And then the transverse fissure is going to be the space between the thalamus and the splenius, and that contains, most importantly, the posterior choroidal artery and the great cerebral vein. The splenium will connect the posterior parts of the parietal lobe, and the temporal lobe, and the occipital lobe. And right here is your cerebellum. Okay, so the tapetum are the fibers from the trunk and the splenium. The forceps major, here it is, forceps. Here's the tapetum right here. But the forceps major is part of the splenium that connects to the occipital lobe, and it works as an interhemispheric transfer of information for the bilateral responses in hearing. So problems with the interhemispheric fibers is not going to change anything in personality or intelligence. The only spatial, tactile, and visual systems are going to be affected. So a lesion in the anterior part is going to be kinestic mutism and tactile anomia. So kinestic mutism, they're not going to be able to speak, or a patient's not going to be able to speak or express themselves. Tactile anomia is that even though they can feel things, they're not going to be able to recognize the shape purely by touch, while we can. So if you close your eyes and you feel around, you feel like a cold surface, something kind of like, rectangular, you're like, oh wait, that's my phone. One, that's because it's learned. It's a learned response. We've played around with the phone so many times, we know it by like just touch alone. But for patients with this kind of disorder or lesion, they're going to experience everything like for the very first time. A lesion in the posterior part, there's going to be an inability to read, but they can still write. Okay, split syndrome is going to be a sever corpus callosum, which can either be like, severed on purpose because of epilepsy, or it's going to be congenitally absent. It's also known as alien hand syndrome, so it's involuntary and uncoordinated. And patients can do two separate tasks at the same time, but they can't coordinate the speech and movement. So, because of the decussation in the optic nerves and stuff like that, if the patient is shown like a word face on the right side, since it's going to be processed on the left side of the brain, if this person is right-handed, that's the caveat. If this guy is left-handed, he's going to have like the correct response. But anyway, so it's flip-flopped if it's left-handed, but this patient is right-handed, so dominant side is going to be responsible for speech. So he reads the word face and he's able to communicate face. However, if it's shown on the left side, the because of the decussation, right? He's not going to be able to process what the word is. He's not going to see anything, or he might not recognize the words, and it goes to his brain. But since there's no communication, he's going to be surprised that he was able to draw a face. Okay, so the anterior commissure, right here, are small bundles of white fibers, and they connect the posterior neocortical part of the temporal lobe. And it connects the olfactory regions together and across the lamina of the pineal stalk. Well, the posterior commissure will cross the lamina of the pineal stalk, and those connect the superior colliculus and the pretectal nuclei. The habenicicular commissure will connect the superior stalk of the pineal gland to the habenicular nuclei. The projection fibers are going to connect the cerebral cortex to the subcortical centers, and that will be the thalamus, the corpus striatum, and the brainstem. The cortical fugal fibers are going to be your descending fibers, while the cortical pedal fibers are ascending. And those will make up the corona radiata and the internal capsule. So here is your internal capsule. That's it for now. Thank you for your attention and good luck studying.